Okay, good evening, everybody. So today we're going to be talking about special types of systems of equations, and again, this is nothing new. We're kind of putting a few things together here, but no new concepts. This should be a relatively short flip lesson. Okay, here we have two equations here, and it is a systems because I have two equations with two variables, and so we have a number of ways of solving it. One of the ways, of course, is graphing. Another one is elimination method, and the third one is substitution. And at this point, what I'd like you guys to start to do is decide which of those three is the best one for each problem. So look at this one. I probably would not pick graphing because it's not both in y form, so I have to do some work there. I probably would not do elimination method because not all of my x's and y's are on the same side of my equal sign. I don't like that my equal sign is not lined up. So for this one, I probably would do substitution. And what I'm going to sub in for is for my y. So my y right here is equal to that right there. So when I sub that in, I'm going to use parentheses. So I get 3 times 3x plus 4 is equal to 9x. So I took this 3x plus 4, which is right here, and I plugged it in for that. So I still have the 3. I did something wrong, sorry. Let me add my plus 12 in there. Uh-oh. Okay, sorry, there I fixed it. So then I forgot my plus 12. Whoa, that's a big old Smurf looking thing. Alright, let's try that again. Get to a decent size here. Then plus 12 is equal to 9x, like that. Okay, so so now what we want to do next is we want to distribute. So I'm going to get 9x plus 12. Terrible. Plus 12 plus 12 is equal to 9x. And so then I'm going to combine like terms. And so I get 9x plus 24 is equal to 9x. And then my last one is to subtract 9x from both sides. And I get 24 is equal to 0. Of course, 24 is not equal to 0. That doesn't make sense. So that means that for this problem, there's no solution. What that means is that these two lines never cross. This line here will never intersect this line here. Two lines that never intersect or never cross are called parallel. These two lines are parallel. They have the same slope but different y-intercepts. That's what makes lines parallel. They have the same slope but different y-intercepts. Parallel lines never cross, so for this one there'd be no solution. Alright, take a look at the next one. Okay, so on this one, again, we have another systems of equation. We have two variables and two equations. So again, I'm going to figure out which would be the best way for me to solve this. This one, I think I probably would use the elimination method. It's set up quite nicely for elimination method. I don't like the fact that this is positive and this is positive and that's negative and that's negative. I want at least one of these signs to be different from the other, or one of these signs to be different from the other. So since I don't have that, I'm going to have to multiply by a negative number to change my sign. That's what we do. And then what I like to do, I guess, is I like to make this the same coefficient. So since that's a 2, I would like that to be a 2. So in order to do that, I'm going to need to multiply this top one by negative 2. So negative 2 times 1/2 gives me negative x. Negative 2 times negative y gives me positive 2y. And negative 2 times 5 gives me negative 10. And now I've gotten what I wanted. That is the same coefficient here, but different signs. So then I can combine like terms coming down. So x minus x gives me 0. Negative 2y plus 2y gives me 0, and 10 minus 10 gives me 0. So what I end up with is 0 is equal to 0. That happens to be true, but what does it mean? What that means is that this is all solutions. Just like the last one we had no solutions, this is all solutions. What this really means is that this is the exact same line as this, just written in a different form. These have the same slope and the same y-intercept. Okay, so both these have the same slopes and the same y-intercepts. So if they have the same slope and the same y-intercept, they're actually the exact same line. Therefore, all points would be intersection points. Any x you plug in here and y you're going to plug in here is going to make this one also true. So all solutions for that one. Okay, so that's the second example. And the last one that we have here is, last slide is, okay, I'd like you to set up a chart. Looks like this. These are different types of solutions that we have and problems that we have. And I'm going to start filling in the chart, and then we'll talk about it, and you should add fifth color as needed. So the first thing we have is, what if we have one solution? Okay, if you have one solution, that means that we have different slopes. That's all it means. The y-intercepts may be the same, but the slopes are different. Okay, if you have one solution where two lines cross exactly at one point, that means that we have different slopes. And so a graph of that one would look something like this. Here's my x and y axis. And you would have one line that goes like that, and another line that goes like that, or whatever. Doesn't matter what the second line looks like as long as it crosses exactly once. Okay, so there we go. So that's what our information looks like if we have one solution. Now, what if we have two solutions? Excuse me, what if no solutions, not two? No solutions. That means that they have the same slope, but different y-intercepts. Okay, it also means the two lines are parallel. Okay, that means they're parallel. So what that graph would look like would be like this. Here's my graph. So one of my lines goes like this, and the other line goes like this. So these two lines are parallel. They have the same slope, but different y-intercepts. So they're never going to intersect. And the last one is infinite solutions, or all solutions. Okay, so for that one, they have the same slope and same y-intercept. Okay, same slope and same y-intercept, and that graph would look something like this. There's my x and y axis, and one line would be like this. The other line is right on top of it, just like that. So they're the exact same lines. When you draw this in your notes, make sure that you can see that there's both blue and green lines, one on top of the other. So make the green line maybe a little bit bigger than the blue, and so you can see it better. Okay, that's the different types of systems of equations. We've now pretty much covered all of the systems of equations, and those are the types and 3 different ways to solve them as well. All right, see you guys tomorrow. Bye-bye.